SMR panel. It is the front view of SMR panel. On the top right corner, serial number of IPS is marked, which is same for AC and DC panel. This is the display of SMR panel. Various parameters indicate on this display like AC voltage, AC current, DC voltage, DC total current, battery charging current, battery discharging current. Apart from these, some fault indication are also indicate on the display like mains fail, battery fuse fail, load fuse fail, MOBD, mains on battery discharge, and the discharging condition of battery bank. This is the DSCA keypad. By this keypad, we can read and adjust wide range of parameters like float voltage, boost voltage, AC over voltage, AC under voltage, AC span, 50% depth of discharging, 60% depth of discharging, 70% depth of discharging, system current, battery current limit, AC current limit, temperature compensation, float to boost current and boost to float current. There is also an option to restore the user setting to default setting. With the help of this keypad, we can directly interface with microcontroller. Adjustment procedure for these parameters is written in this instruction. To adjust, first we have to select user setting by pressing the set key. After that, we have to press enter key. To go into the setting, we can increase the displayed parameter by pressing increase key and can also decrease it by pressing decrease key. To set the adjusted value, finally, we have to press enter key. To adjust another parameter, we can follow the same step and can access the next parameter by pressing set key. This is the main input switch of SMR panel. These are the input MCBs for individual SMR. These are SMR module. Top 4 SMR are running on load in N+1 configuration and fifth one is cold standby. This is the front door of SMR panel. On opening it, we observe the front internal view of SMR panel. This is the input 230 volt AC terminal of SMR panel. Input supply is fed through these terminals. Thereafter, the supply enters into the filter line choke through a fuse. This choke reduces the distortion of input supply. Then the supply enters into the static switch, which actuates during under and over voltage. There is a rotatory switch thereafter. The output of this switch is fed to the input MCB of individual SMR. This is SPCL 157 card, which is used to extend the fail signal of IPS to data logger. This is our microcontroller based DSA, distribution supervisory and control alarm module, which control various parameters with the help of microcontroller. Moving to the back side of SMR panel. This is the input strip for all the SMR modules. From here, 230 volt AC input supply is given to all the SMR modules. 110 volt DC output of all the SMR module is drawn from these connectors. There a control cable is also connected with each SMR and all the cables are connected to this sharing card. And the final output of all the control cable are given to the DSA. Output of all the SMRs are given to this common bus bar and the final output of all the SMR are drawn from these wires and fed to 80 ampere main fuse F9. Then the output of F9 is given to this strip and 3 different fuses are given to point machine, DC panel and AC panel. With this supplies goes to their respective terminals. There are the terminals through which we supply 110 volt DC for various applications like SM card, display and teleoperation. This card provides protection from reverse polarity of battery terminals. In case of reverse connection, a red indication glow and the buzzer sounds. This cards take 110 volt DC supply from SMR and provide it to battery terminals. A battery fuse is also given between this card and battery terminal. Negative wire from SMR output is directly provided to the shunt. A SPD surge protection device is also provided with point machine terminal.